Yo, what's gravy? Um, Hold up. Where's our boy at? Oop, the dog be sighing. Why the dog sighing? Bum, bum, ba-da-dum. Um, okay, and we want to. Come on, give me. Where's our boy at? There he is. Uh-oh. Hold up. Playback speed. No. Hey. Whoa. What's going on, everybody? Welcome back in. Hope you're having a good day today. Welcome back. Welcome back. Welcome on. Welcome on. My name is Michael, and today we're going to be back streaming, learning some C. Big shout out to everybody. Got a lot of love on the first video of the read along. Wow, wow, wow. We over 2K views on that bad boy in 2 days. That's crazy for the channel. I've never gotten videos that get that many views. So really crazy. Thank you guys so much for the love on that video. It's at 2.1K. So yeah, I just dropped actually chapter 2. So we read chapter 2 yesterday in its entirety. And we are going to be going back through and solidifying our knowledge today with some note taking. Going to polish up our notes and tackle the problems at the end of the section here. Hey, Unlink, how's it going? We're getting back. We're starting it today. CB going. I see you, my friend. I see you. All right, let me know how the music is. Is it too loud, too quiet? Let me know. I can turn it down, turn it up. Let me know about my mic if you want it up or down. All right. Hey, we got a sub on Link. Thank you for the sub on Link. That's the boy. I can't hear the music at the moment. Okay, let me turn it up. How's that? I don't want it to be too loud so you can't hear me, but let me know. We want to open up the dashboard. Yo, yes, Mr. Lance. Welcome back in, my friend. It's good to hear from you again. What you've been working on, what you've been studying. How you been? All right, everybody. Okay, we got the Streamlabs loaded up. All right, let's go back through and let's see if we can tackle some of this note taken on chapter 2 here. So again, guys, we finished chapter 2. So if you'd like to go back and watch the full VOD, that was yesterday's stream, or you guys can go watch the recent upload for the chapter 2 read along, the condensed version. It is uploaded just tonight. I just uploaded before stream today. Also, if any of you guys could, Lance, you're on the YouTube, if you could let me know, are you able to view on my channel all of my past VODs? Like should have over like 400 live streams from us live streaming almost every single day this past year, and sometimes 2 times a day, sometimes even 3 times a day. Are you guys able to see and access all of those? I get a few comments every now and then saying like, where are all the VODs? And I can see them, like all 400 of them on mine. Yeah, they seem to be there. Okay, good. Wanted to make sure YouTube wasn't like taking them down after some time. That'd be really frustrating. I don't have any way to, I didn't record any of that stuff. It's just on YouTube servers pretty much. Okay. Let's get into today. Let's get going. I appreciate you for checking, Link, and everybody else was checking. Havoc Blades. Havoc bleeds. Let her rip. I like that name. Okay, let's get going here. Okay, so we were on 2.2. We wanted to take some notes here. 2.2, if you remember, got into directives. And so the general form of simple program. So it had these directives, which were things that started with the hashtag, right? If we go back here, we didn't learn about those yet. So that's where we're getting into these here. So we have directives, which are, before a C program is compiled, it's first edited by a preprocessor. Commands intended for the preprocessor are called directives. So commands intended for the preprocessor prior to compilation, right? For now, we're interested in only these ones. Cool. What does it say about the hashtag? Yeah, here we go. So directive states the information that the information in standard I/O is to be included in the program before it's compiled. Standard I/O contains information about C standard library. C has a number of headers. Okay, so headers are .h files, right? There's a number of headers like standard, which contain information about some sort of part of the standard library. So headers are .h files that contain additional functions / code to be imported, right? To be included into the program before it is compiled. Hey Patrick, how's it going? Headers should contain definitions, not the actual implementation. Definitions, not the actual. Okay. Like macro definitions, right? Exactly. Files that contain additional functions / code to be included in the program before it is compiled. Each contain information from some part of the standard library. Got you. So, for example, standard IO.h is one of them. Each contains information from some part of the standard library. The reasoning we're including this in C, unlike some programming language, has no built-in read-write commands. And we'll say like this, right, is the standard IO library. Directives always begin with a hashtag character. Always begin with the hash character, right? With a hash character, which distinguishes them from other items in the program. By default, directives are 1 line long. 1 line long. There's no semicolon or other special markers at the end. No semicolon. Okay, cool. Do we need definition? Do we need to take notes on functions? We'll do it to be well-rounded in our notes here, you guys. Functions, we'll just do this one fast. We know what functions are. like procedures or subroutines in the program. The building blocks of which program is constructed. In fact, the C program is a little more than a collection of functions. Functions fall into two categories: those written by the program, those part of the C implementation. I'll rather refer to the latter as library functions. Since they belong to a library of functions, they are compiled supplied with the compiler. The term function comes from mathematics, where function is a rule for computing a value. C uses the term function more loosely, and C, a function is simply a series of statements have been grouped together and given a name. Some functions, okay, here we go. Simply a series of statements have been grouped together and given a name. Some functions compute a value, some don't. A function that computes a value uses the return statement to specify what value it returns. It's kind of like a little bare bone definition straight out of the book. I'll take. It's kind of a pretty vague definition, right? But we can add some more statements here. Uses the return statement to specify what value it returns. Just based on the mention of procedures and subroutines. Yeah, I bet you it's a little bit of an older book, but the core root of the things are C99 is there. Obviously, some things were added in C, probably later C's that we'll have to revisions that we'll have to learn and things like that. So we'll get there. Over to what's going on, my boy? How's it going, you guys? Welcome in. Appreciate everybody being here. If you guys are enjoying the stream so far, smash a little like, skis, if you could. A function, cool. Although C programs may consist of many functions, only the main function is mandatory. So main is special, gets called automatically. So we'll say, we'll go into here and go main is the only mandatory is the only mandatory function within a C program that gets called automatically when the program is executed. Okay. If main is a function, does it return a value? Yes, it returns a status code. So we'll say, I guess I'll make this its own thing. We'll say, returns a status code 0 or 1 that back to the operating system. Right, when the program terminates. So the word int just before this describes that, yeah. We have that here. I'll say line 8, right? Or like, I don't think you can see lines in this actually, right? Section 2.1. Can you like get a link back to a certain line? Like in Markdown, can you get reference to a certain section? And like have a link back to said line? I wonder, I bet you can. In Markdown, can I ref back to a specific section of text in my file, href or something like that. Yes, Markdown, you can create internal hrefs. The point. So go to details, so hashtag details. When Markdown convert headers to IDs, it's typically like this. Okay, so if we need to go to, if we're going to do that, we have to say, so what happened? Or we'll just ref back to 2.1, right? See here. And then we will, what did it want us to do? It wanted us to use, okay, kind of like Discord. Oh, I think Discord is Markdown, right? And then we would do 2.1. Hashtag identifiers, layouts, or program chapter 2 fundamentals. Writing a simple program. Yeah. Now if we ref this back and we go here, we go boom, right back here. Nice. There we go. Nice. See writing, we'll go 2.1, writing a simple program. We'll say C 2.1, writing a simple program, for example. Nice. Okay, I like that. Alan, how's it going? Thanks so much for coming in. Honestly, most C code bases are still C99 or C89, or even newer projects. Hey, bro. Hey, Foaz. Appreciate you for coming back tonight. Welcome back in. Double feature. He's back. The boy is back. The prodigal boy. Okay, let's keep rolling. Again, guys, we already read chapter 2 today, or yesterday. We're going back through today, solidifying our knowledge. We'll take with our finishing up our notes, and hopefully tackling into the end, the practice problems at the end. If we have some time, we might have to do even another stream tomorrow to finish up those practice problems, because I got off work. I got off work late today. I have basically, let me give you an update. I have basically almost finished my, basically a minimum viable product, but kind of more of a beautified, actual real product, but has all the basic features that we need for my tool I wrote for the company. It actually has a full, graphic interface for people to, load, their data frame of constituents into there, and then select, parameterize them through some configuration parameters, and then obviously run and have some status code updates, with some labels. And it's nothing really crazy, but it's pretty just clean and nice and pretty and structured and official, and it does what I need it to do. So I've been just debugging it, kind of polishing up the features the past day or so, day 2, but but it's all there, and yeah, it's pretty cool. I'm quite proud of it. I don't know if you guys have any experience. I would like to know, what is if you guys have any experience with official corporate software. I don't. My company, I'm a biochemist. It's very analog. It's very wet lab based. It's very physical tanks, and our assay machines still run on Windows XP and things like that. So some of these things are really old. These immunoassay analyzers and stuff. They're just really expensive, but they're obviously, they still get the job done. And the code, I bet we were coded probably in C. I bet you. So which is going to be kind of interesting. Like, Roche and Beckman and Siemens, all these companies. Pause. That is a real company. Anywho, I want to know, like, does anybody have any, like, experience, like, with companies that actually write software? Like, what is, like, an official process for, creating tools, and how would you go about, publishing them for the company to use internally? Like, what sort of verification would typically you have to go through, and regulatory would you have to go through, quality assurance, and, like, how would you, because it's nothing like, it's Python objects and script. It's a pretty advanced, not like advanced, but it's like an advanced, like, script using linear programming problem in a linear programming library that is not, like, it's not crazy. The math isn't so crazy, but it's just kind of elaborate. There's lots of things going on to make this thing run, and so unless you have an actual experience, like, building one of these physical matrices in the lab, you probably wouldn't be able to, like, figure it out. You would be able to figure it out if you did it once or twice, but it's just like, once you get that skill, you'd understand what's going on. But trying to, like, talk about it would just be like hitting my head against the wall. Like, it just wouldn't convey that well. Like I've told you guys, it's basically predicting, like, a yield and a feasibility, an optimal feasibility, if you blend an array or a vector of serums together in some sort of combination to hit some sort of targets. But your vector of constituents, all have different, contributions for their individual vectors of constituents within them. So it's like you blend together a blend. It's like really it's funky, but we got it to work and figure out. And, like, I just want to know, like, because I'm trying my best to figure out a way to kind of bridge the gap with the non-technical, like, side of this company. Like, it's just, there's not, if Windows, if Excel and Microsoft Office went away, it would die. Like, it's just like, it's so ingrained in people, they think, like, chemists and stuff still, and chemistry company, biotech companies and stuff. Like, so there's no formal process, and I can't really, like, talk too much about it, because I'm trying not to get, like, obviously get myself in trouble, but I'm also trying to learn along the way, like, the right way of doing things in this kind of environment. So I don't want to be, I want to make sure I cross all my T's and dot all my I's when I give software to my peers, that it's in the right format and it's, like, proper and whatnot. And I don't know, I don't want it to be a mess. Hey Hades, how's it going? Well, the easiest thing you can do is at least sign your code, and only allow running code with a valid signature as a policy. That would mean you can still just share it easily via a file server, but at least you won't run random code. Then again, I'm uncertain if Windows is being... we have, like, Windows, like 11 and stuff on our computers and all that, but I'm talking about, like, our immunoassay analyzers. Like, that software is all really old. Hey Catzilla, tell me what you want to be. I don't know, dude. That's what I'm trying to. I don't even know. I'm trying to figure that out, my friend. My 2 cents, you always keep improving as a dev with time, so just keep making stuff over time and learn what's best for you. Cool. That's good advice. Because, like, it's a Python, it's not a very large Python script. It's, some Python objects and overall main script, and then some, like, a Tkinter interface. And so I was planning on just compiling into an executable with some sort of Python library, and then using that. But again, like they don't even use like there's no like I mean, they do have it for their like file systems and stuff, that like for SOPs and MPIs, manufacturing process instructions, and standard operating procedures and stuff, their file revision system. But there is no like GitHub or Azure DevOps or anything for this division of the company, because it's so like analog. It's like there is no code on the site. Like it's like that. So I don't know, dude. I'm kind of, I don't know. It's gonna be interesting. Most people's code is dog. Mine is a prime example. Still, if it's better than before, it's a step forward. Hey, how's it going? How's it going? We got a lot of people on Twitch here today. Projects grows fast, and don't try to live. Yeah, I like that advice. It's good advice, y'all. The Twitch crew got good advice tonight. Okay, let's keep going on our notes here. So we read, remember guys, yesterday we read chapter 2. If you guys want to go back to yesterday's stream or the recent upload, you can check it out on this channel. We're going back through today and just going and updating our notes for chapter 2. We're making sure that we keep up with this. I don't want to fall behind. It's easy to procrastinate the notes and stuff in the practice problems and skip forward. And then next thing you know, you're having to go back and relearn stuff because you didn't get the solid foundation. So I want to make sure I get everything done before I move forward. We're not in any rush, but I know it can be annoying when I sit here and ramble for a while. Okay, so we wrote in the return status here. Return at the end of the main function of the program still terminates, however many compilers produce a warning message. If you don't have it, okay, whatever. Statements. So statements are is a command to be executed when the program runs. We'll explore statements later in the book, primarily in chapter 5 and 6. Punz.c uses only 2 kinds of statements. One is a return statement, the other is the function call. So these are like examples, return, and my func call, right? Who was that? Hey, Nebularis. Killing me, dude. Thanks so much for coming in here. I was actually involved in establishing a huge part of our software division. I work for a hardware company. Oh, that's cool, dude. That's really cool. It's hard starting from zero, but taking it slow totally works, even if things get messy. Yeah, dude, I don't even know, like, that's the thing is, I don't even know, like, where to even, like, because with such a large company, everything is, like, regulated, so, like, I can't even, like, implement anything, I don't even think, like, on my own without, like, approval. So, I told, like, my project managers and stuff, like, yo, I got this kind of project ready to go. I'm getting towards the end, and I've been telling them, like, we need to kind of get on the ball, like, for, like, regulating this and getting it into the system or whatever, and I don't know, people don't really know what to do. It's okay. I'm just worried that if I ever leave or something, I would like the code to still be used in the future, because it is really helpful. Like, you no longer have to do any math on your own. It's so awesome. No interpretation. It's great. Okay, so asking a function to perform its assigned task is known as calling a function. Okay, we know that. C requires each statement to end with a semicolon. There's one exception when the compound statement, which we'll cover later. The semicolon shows where a statement should end. Okay. Printing strings. Printf is a powerful function that we'll examine in chapter 3. So far, we've only used printf to display string literals, a series of characters enclosed in double quotation marks. Okay, so we have string literal, which is a series of characters enclosed in double quotation marks. Right, we know that. When printf displays a string literal, it doesn't show the quotation marks. We know that. Printf doesn't automatically advance the next output line. Use the \n new line character in the string to be printed, right? Writing a new line character terminates the current output line. Subsequent output goes to the next line. So then you have this character with \n, which we know is the new line character. Moving, terminating current output on the current line, and moving subsequent output to the next line. So I'll do a little subheading here of printing strings, or maybe like this. Okay. Cool. Nice. Okay, awesome. Moving on to 2.3. Why C, why not C? Printf. Hey Tim, welcome back in, dude. Yeah, we were made a separate departments. We just had authority to just get stuff done. Why not C? That's a good answer. To C or not to C? Okay, comments. Two types of comments. Number one is this is a comment. That sucks to write. Number two is this is a comment. Right? So this one requires opening and closing symbols. Opening will do, right, E. And closing. It's probably inferred, but we can just be extra thorough with our notes. Symbols to encase the comment text. This can wrap to multiple lines. Can wrap on multiple lines. Yeah. And then, cool. And then this comment just requires the opening symbol, opening, symbol, only opening symbol, and restricts the rest of the line to a comment. Something like that. What do you guys think? Do you know about Harvard's CS50 Intro to Comp Sci online course? Yeah, we already did it. Yeah, we already did it. Bro, my few knowledge, I know when people wanted to learn programming, they go video tutorials for learning programming, but you read books for learning programming, read books, learning practice is more effective way to learn programming. I don't know. I've heard different things, honestly, from my point of view. I think that there is something different that happens with. I have no scientific backing, but from my experience and from my feelings, like there's something I think that happens with your brain through physical interpretation of characters as you read, and then the processing that happens of that information, because in order to absorb the information, you have to read the words on the page, right? Whereas with a video or a lecture, it's quite easy to daydream or to find yourself missing portions, and then if you're in a live lecture, you can't go back. But if you're in like a video, you can obviously go back. But it's all, I think it's just easy to just move forward in videos. But with like books, like, I don't know, there's something going on with the physical interpretation of the characters in your brain, and then interpreting what the entire sentence made up to convey the messages of computer science versus visualizing only, and then potentially like missing it through abstract thought or whatever. I don't know. That's just my 2 cents. It's kind of just philosophical, honestly. It's not even, there's no backing. What do you think? Let me know what your guys' thoughts on that. That's a good question. What do you guys think about that? 2.4, variables and assignment. Few programs are as simple as the one in section 2.1. Most programs need to perform several calculations, right? So variables. Storage locations. A way to store data temporarily during program execution. My headphones died, you guys. I'm sorry. We'll have to pause on the tunes for a couple of minutes while I let these bad boys charge. I often forget that they're in my ear, like just throughout the day, and so they will be on low battery when I get home. Okay. I will keep playing the music though. I'll just turn it off on my end here so you guys can still hear it. There you go. You guys can still hear the tunes, but I cannot. So let me know if it like changes. I think I have plenty of time with the song. Okay. Okay, let's see here. A way to store data temporarily during program execution. So we have types. Every variable must have a type which specifies what kind of data it will hold. A description of what kind of data a variable will hold or holds. Right? For now, we'll limit ourselves to just these two, int and float. Choosing the proper type is crucial since the type affects how the variable is stored. The type of numerical digits, largest and smallest the variable can store, it also determines whether or not digits are allowed in the decimal point. So the type of a numeric variable determines the largest. So there's numeric types. which determine the largest and smallest numbers that the variable can store. It also determines whether or not digits are allowed after the decimal point, as well as is that one word or two? I can't remember. I can never remember. As well as whether or not digits are allowed after the decimal point. Okay, so we have some examples here. Int, and we have float. These are just the ones given for now. Int and float. Short for integer. Can store a whole number such as 0, 1, 392, or should we say a signed or unsigned whole integer? Signed or unsigned whole integer. Signed or unsigned, which is, we'll say positive, negative, whole integer, right? Or even 0. Is 0 considered a whole integer? Well, yeah, whole numbers such as 0, 1, or yeah. We'll say like 0, 1, like 0, 1, 392, or negative 2, 553. Kind of overkill with the notes, but we're being thorough, you guys. We're being thorough. Okay, a variable type float, short for floating point, short for floating point. Can store much larger numbers than int. Ooh. Ah, come on. Oh my gosh. Can store much larger numbers than an int variable. Furthermore, a float can store numbers with digits after the decimal point, as well as numbers after the decimal point. Arithmetic on float numbers may be slower than arithmetic, so we'll say drawbacks. We'll say float drawbacks. Are or we'll just say on float can be slower than right, and then most significantly, the value of float variables often approximation. the value of a float is often just an approximation of the numbers of the number that was stored in it. If we store 0.1, so we'll say like example here, float num equals to 0.1 f, right? Could have a value of, could be, so if you call print to num, if you call printf to num, could you get this? Is that what that's saying? Like, or how would you be able to see this value? Let's go back up and catch up on some chats that people had. Okay, bro, in my few knowledge, I know when people wanted to learn programming, they go to video tutorials. Oh, that was before I already read that one. Oh, Kat Hades Zaz, how did you find it challenging? Yeah, actually, I did. Honestly, that's why I kind of want to go back through C. The first couple of weeks of that course were like of the C part, where I did learn a lot of the types, but it still was a little fuzzy. Honestly, I kind of brute forced my way through some of those problem sets with like just trial and error. I kind of really fully didn't understand some of them, especially like the Tiedemann one. I kind of had to get some help on that one. Some of the other ones, like the money ones, those were fine. That we had to use module operators, and I was already kind of familiar with that stuff. But more of the things where you had to memory, obviously creating arrays and allocating, memory size bytes and stuff for your distinct size of data types was a little bit, still was fuzzy, but I really liked the filter problem that we did, where we created filters over images. That was really cool, and stuff like that. So I wanted to dive in more to that kind of stuff. Catzilla says the best thing is doing little projects. That's a good way too. Definitely. I think better reading than watching personally. Chunling says he likes reading. A lot of people agreeing with reading. Jimmy, hey, what's going on, Jimmy Boats? See, eh? Yes. You see that, huh? What compiler are you starting with? I don't know. We haven't actually had to compile any code yet, so I'm sure we're going to have to get into that soon. Probably tomorrow when we work on the practice problems for the end of chapter 2. For me, it's the act of writing that triggers that. String is a real stumbling point for C. Don't think it's their official string library. Float drawback, most compilers won't auto cast it to int or double. Try it, did it make? Link lists. I think there was a problem in there where we had to do something with linked lists in yeah, I think so. That was in the Tiedemann one. That was the linked list problem, I believe. 0.09999999987 due to rounding error. Okay. So let's keep moving. We're gotta keep moving. This is taking way too long. Declarations. Variables must be declared, described before they're for benefit of the compiler, before they're used. Okay, so variables must be declared before they can be used. You specify the type in its name. So we'll say like example is int num, right? And we say this is going to be equal to 5. Right? Or you could say int num by itself. Right? You can declare it right there. Cool. We first declare it. Gotcha. You can declare multiple in a row. So we'll say int num or int like height and height width. Or int like this, or int 5. Gotcha. Examples. Okay. Notice that each complete declaration ends with a semicolon. Our template for main didn't include any declarations. Got you. True functions in general, we'll see as blocks. Containing embedded declarations. It's good to ideally leave blank lines between declarations and statements. And seen in 9 don't have to come before. Gotcha. The numbers 8, 12, and 10 are said to be constants. So assignment. A variable can be given a value by means of assignment. Right. Oh, so that's like this. So maybe we should take this example and put it below. Okay. Decimal point. Okay, so we have floats here. So we need to kind of say we'll do this. Assigning float types requires appending f to the end of the number for further clarification to the compiler. I'm going to take this and ask AI, can you rephrase? When assigning a float value, append an F to the end of the number to explicitly indicate the type to the compiler. When assigning a float value, append a literal F to the end. So int, we'll say float decimal equals to like, I don't know, 3.14 F. Cool. Another variable, got you. You give an expression. Another. Printing a value of a variable. Okay, so yeah, printf, printing variable values. Here, so we'll do this. We can use printf to display the current variable. Use the printf function to display the current value of a variable. So you have these placeholder characters, placeholder symbols for different data types, variable types. So you have like here, you have %d is for a digit, or it stands for digit or integer. Right? Is an integer. Int. Right? This stands for like digit. Two here is percent F for float. So for float, you can display the p number of digits after. You can put a dot p digits between the percent and the F that you would do. Right. So to do a placeholder, you have %F here, and you do, so for digit rounding, you could do like, for p digit, p number of digits after the decimal would look like this, of percent dot p f. We'll say to display the p number of digits after the decimal, use dot p in between the percent and F. So, okay. You have a Mac. As a side quest, if you don't know Bash, you should learn Bash. It'll make a Mac 10 times better. Yeah, I don't have much knowledge with like that kind of terminal stuff. Hoping to get into that as we get more into like this lower level. I don't know. I don't know if it's even necessary. Like, it just seems kind of daunting. Hey, Akon Tex, how's it going? I appreciate you coming in here. Welcome, welcome, welcome. The Twitch has been bumping today. A lot of people coming in on Twitch. Lynch G, thanks for the follow on Twitch like a little couple minutes ago. Okay, let me put it back in my headphones so I can hear. Unless these are dying. He's dying. Yeah, they are dying. Okay, cool. Yeah, they're dying. I forgot to I didn't put them on the charger. That my case wasn't charging. No. Okay, now they're on the charger. Okay, so this is just an example of computing the weight of a box, right? So initialization here. Right? Some variables are automatically set to 0 when a program begins to execute, but most are not. A variable that does not have a default value has not been yet assigned a value and is said to be uninitialized. When a variable is assigned a value, it is then initialized. Variables without assignment are considered uninitialized. Second spelling. Okay. Attempting to access a value of an uninitialized variable, for example, may yield unpredictable results. Accessing an uninitialized variable via a printf reference could lead. What is it called to reference an uninitialized whatever variable via printf? Referencing or using an uninitialized variable in printf statement or anywhere in your code is called undefined behavior. Is called could lead to and is called undefined behavior, right? Because you're accessing some random place in memory. Or even crash. Kind of it's undefined. You really don't know what it's going to do. Pretty good at working on some stuff. How's it doing? Nice. I'm just learning about some C here. We're reading C Programming, a Modern Approach, going back through chapter 2 today. We read it yesterday in its entirety, and we're going back through and polishing up our notes today. How are you doing? Oh yeah, you already said that. Sorry. You guys are in here, you could give it a like. I appreciate you guys so much. Thanks for joining me. Okay. We can always give a variable initial value using assignment, of course, but this easier way. Put it in its declaration. An initializer. So we'll say an initializer is the value, a value that is assigned to a variable during its declaration, at the same time of its declaration. Oh, it can be assigned in the same declaration. Is a value that is assigned to a variable. Right. Is that true? A value or expression used to assign an initial value to a variable at the time it's declared. So it is at the time it's declared. So an example of this one would be, right, int num equals to 5. We would say 5 is the initializer okay. Mac is so nice. If you start living in the terminal, you will fall in love with it. Yeah, we got to get more into the terminal. We got to grow out our neck beard and start getting into the terminal, right? Yeah, I was destroying my head with Rust and had to cool down. I wrote that README for my project, so now I'm back again. Oh, nice. Awesome. What have you been building in Rust, my boy? What's going on? How's that been going for you? Okay, printing expressions. This last thing here for this section. Jeez, printing expressions. Printf isn't limited to displaying numbers and stored variables. It can display the value of any numeric expression. Okay, so I'll just do this. We'll do the example here. We'll just do this, and then we'll take. I want to take this. Let me do like this. Which one? Can I do this? Oh, is it capital? Oh, it is working. And we'll say this way here. It doesn't like the percentages. Okay, so I guess we'll just do this. oh, sorry, we don't even need this part. That's what it's trying to show us, is that you can do arithmetic within this expression, right? I'm making an overlay in telemetry at desktop apps of sim racing games. Oh, nice, dude. I make an overlay in telemetry desktop app for sim racing games. Sim racing games, like with like a controller, or like what is sim racing? Okay, cool. Let's move on to 5 here. Let's go back. Again, we already read this chapter yesterday. We're just going back through and polishing up our notes here. So we have scanf, right? We learned about scanf where you'll obtain input. We'll use the scanf function. So you have scanf, which is a function for my streams to specify the appearance. Right, so scanf is just a way to get input from the user. You need to allow the get dimensions to obtain input. We'll use the scanf function, C library counterpart to printf. The F in scanf is like the F in printf. It stands for format. Both scanf and printf require the use of a formatted string to specify the appearance of the input or output data. Scanf needs to know what the form the input will be. Just take the printf. Okay. Function to get input from the user via the console. Is it via the console? I wonder if it's the console. It doesn't have like a solid def. I would like to know here. The console store in more verbal, yeah. So it requires, right, it needs to know what form the input requires. It needs to know what form the data input will take. What input data will take, like int, float, etc. Right? So for example here is this guy. Take this guy in its entirety. Scanf reads an integer into its entirety. So it takes in this %d and stores the value in I. So the %d string tells scanf to read the input and represents an integer. I is an int variable in which we want scanf to store the input variable into. Okay, right. The %d string tells scanf to read input that represents type int scanf to store the input. The %d string tells the scanf to read input that represents an integer I Gosh. Yeah, okay. The %d string tells scanf to read input that represents an integer. I is an int variable that we want scanf to store the input into. And then we know that the ampersand, not mentioned, we'll say ampersand, oops, that's not ampersand. We'll say not mentioned in the chapter. Right, we know is the references the memory location of that place, right? So accesses the memory location references the memory location, right? Is it references the memory location for this new int I variable to save the value at said memory location. Let's get some feedback on this one. The %d formatter or specifier tells scanf. So string / format, I like that, format specifier. Tell scanf to read an integer value. The value variable I is an int that will store this input. The ampersand operator, though not yet covered in the chapter, provides the memory address of I. Provides the memory address. The memory address, I like that word, address, for this new int I, allowing scanf to store the user's input directly at that location. Right. Hey Ray, how's it going? Sim racing games are racing games that try to simulate real driving as good as possible. Something like Assetto, Coursera, iRacing, but not something like Forza or Need for Speed. Many people play with a wheel, yeah. Oh, that's really cool. Like, you really try to get, like, the physics down. Now, can you play with, like, a controller? But it's your goal just to try to get it as realistic to driving as possible. That's really cool. I wonder, like, that'd be kind of like a challenge, actually. Like, I wonder if you could, if, like, I don't know, that'd be kind of funny. You'll have to send us a demo video or something. Hey, Blasto, he's back. The boy's back. Nice. Welcome in, Nito. Welcome in, Nitot Ghetto. Nice. Welcome. Sounds good, my boy. Yeah, we're learning some C, diving deeper past our Python roots here. We've been learning, teaching ourselves Python for over a year and a half now. We've written some pretty cool projects in Python so far, and we're starting to dive deeper into some more lower level programming here. So, welcome. My name is Michael. I'm 26 years old. I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company where I make and manufacture biological controls and formulate them. As well as now I've been coding up some cool automation tools for solving our mathematics automatically regarding our formulations. So it's pretty cool. Yeah, and we've been diving into C here as I've been teaching myself computer science and programming almost every single day here for the past year and a half live on stream. Hey, Jesus, how's it going? Glad you streamed tonight after all. Yeah, we're getting going. I wanted to jump in here and finish up these notes tonight, and then tomorrow we'll finish the practice problems at the end of the chapter. And then that'll finish it up for chapter 2. And then we probably got to jump onto another, switch it up to another book or another one of our other projects, and then we'll come back to this. But our video yesterday for chapter 1 got like over 2,000 views so far, so it's popping off on YouTube. It's going crazy. Okay, Percent %f only works with variables of type float, and assume that x is a float in the variable. The percent %f string tells scanf to look for an input value in the float format. Computing the dimensional weight of a box revisited. Here's an improvised version. Okay, yeah. Here's a question for you guys. Now, is it very wise with this, right? With Python, it's really easy because the input function returns a string every single time. And then we can easily do a try and convert it to a float. And if we get a a value error, we, I believe it's a value error. I don't think it's type error. I think it's, yeah, if we get a value error, then we catch it and then we do something. And, but with this, if you're going to deliberately input, if you're going to force the user to give you an input, can you trust the user enough to distinguish between a decimal and a float, right? Like, okay, give me a number, or give me a number, right? And if you accidentally have D in here and they give you a decimal point, then obviously you're screwed. So what are some protections for that, to maybe like take the length of, I don't know. Yeah, because Python, it's much easier to sanitize with some of these, like treating them as like their individual objects and just doing some very easy try except checking on the conversions. Python's got us, blessed with that. But how would you do that, like in just this simple example here? For just a basic example. Hey SEN, how's it going, my boy? Welcome. Son. No, we don't code in Rust. Sorry, we're Python boys. You have to explicitly make it safe. So how so? Like obviously, like with your question, your interpretation here, right? You would ask for, okay, give me a decimal value, but still, the user could not give you that. So what tools does C have or whatever to sanitize the data? Because obviously, and then like in Python, like I think I just don't know like what I would do in C other than in Python. Okay, cool. Input a prompt, understand. Nice. Okay. Defining names for constants. Macro definitions. When a program contains constants, it's often a good idea to give them names. Known as macro definitions, we can name this constant this. So macro definitions are like constant values that I don't know, like what is a good definition for macro definition? C. A preprocessor directive in C that defines a name or identifier to represent a value or piece of code. When the program is compiled, and the preprocessor replaces every occurrence of the macro name with the defined value or code after the actual compiler. That's good. There we go. That's good. So like examples here are these. I like these. Copy these. Right. Define as preprocessing directive just as include. pre-processing directive. So I'm going to bold this. A pre-processing directive. Processor directive in C that defined. We already know it's in C. Okay. Nice. So it'll just go in and replace all of those values, just as like you would for maybe like global variables in like a file that's like all uppercased or whatnot with the Python kind of imports or whatever. Hey, Not Sizzle, how's it going? Welcome, welcome. I appreciate you coming in. Yeah, I think that's the common convention, Blasto, is to do that, because there is no constant definition in Python. So the constant definition is kind of like insinuated by Python programmers of doing all uppercase. It's like, oh, this is uppercase. Don't mess with this. Python's funny. Okay. Nice. Cool. Got a little bit of a better definition there. I like that. Okay, so we got the converting from here. This gives another example here. We know that we went over that one last time. Moving on to identifiers here. Almost done with our notes, caught up here. Remember, guys, if you guys are just popping in here, we finished the reading yesterday. We read the entire chapter. Now we're going back through and solidifying our notes here. And then tomorrow we'll go ahead and finish the post-chapter problems. And then we'll be done with chapter 2 in C Programming, a Modern Approach, 2nd edition. So it's been fun here so far. Then we're gonna start actually getting into programming in C tomorrow, like getting into practice. As we're writing a program, we have to choose names for variables. These names are identifiers. So identifiers are the chosen names for variables, functions, macros, and other entities. Right. These are called identifiers. It may contain letters, digits, underscores, blah, blah, blah. Okay, cool. So identifier in C, an identifier contain letters, digits, or underscores. Must begin with a letter or underscore. In C, an identifier may contain, so we'll say, we'll just get rid of this part. May contain letters, digits, and underscores, but must begin with a letter or underscore. Cool. Here are some examples of legals identifiers. So we'll go example here. We'll grab these, go times 10. We'll just grab a couple. Get, next, char, and then done, right? Cool. These are case sensitive. Right? That's important. These 8 identifiers will all be used simultaneously, each for completely different purposes. Since case matters in C, many programs follow the convention of only lowercase, or you could do snake case, or camel case, sorry. It's just kind of getting over some conventions here. So keywords. So here are some keywords. Special convenience in C compilers and therefore cannot be used. Are special words, words predetermined, or special words pre-allocated to functions or other C methods that cannot be used as identifiers. So then we're going to take basically this table here and bring it right in here. Boom. Now let me get a little bit, see if this definition, I like this definition, pre-allocated. Reserved words in C that have like predefined meanings and serve specific purposes in the language syntax. Oh, that's a better definition. That's really good. Reserved words in C that have predefined meanings and serve specific purposes in the language's syntax. They cannot be used as identifiers, such as variable or function names. Nice. Because of C's case sensitivity, keywords must appear in the program exactly as they're shown. Blah 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 blah. We'll say these are also like, you know, case sensitive, right? Watch out for other restrictions on identifiers. Some compilers treat certain identifiers, for example, as additional keywords. Identifiers that belong to standard library are restricted as well. Yeah, we know this. Okay, cool. Now, last section here. Let's cop with some chats. Mang says, I'm new to coding. I'm working with Prisma. Do you have any advice? TWT. What is Prisma? I'm not sure what Prisma is. Can you give me a little bit more insight? Sorry. A lot of C written by neckbeards is very difficult to understand / read, Jimmy says. Kind of like JavaScript can be when people try to be fancy for no reason. Yeah, JavaScript. I sometimes look at some JavaScript code. I'm like, what in the heck is going on with these arrows and stuff? It's kind of funky. Hey, Aurora, how's it going? Appreciate you for coming in here. Welcome, welcome. Have a control keyword go to. Well, it has a go to keyword. Oh, it does go to. Interesting. Keywords. Is it controversial because it's the only one that is 2 words? Interesting. Okay, last section here of notes. Layout of a C program. Series of tokens. Group of characters that can't be split up without changing their meaning. So, tokens. Groups of characters can be split up without changing their meaning. It's kind of, this is kind of like a little bit of a, it's not like super crazy stuff. It's just kind of like good stuff to know about. Obviously, it's kind of like you have to close parentheses and whatnot, and these different tokens and identifiers. Okay. Tokens 1 are identifiers. Tokens 3 is a string. Later on, tokens 4, 5, and 6 are punctuation. Identifiers and keywords are tokens, so operators like plus and minus, punctuation, commas. So are operators like identifiers and keywords are tokens. Identifiers, keywords, operators. Keywords, operators are all, and punctuation. Are all tokens. And then it just gets into like spacing. So nothing really like, I don't really going to take any notes on that. I will, however, take a screenshot of this here. It's a good little snippet here. Oh. Oh shoot. And yeah, then goes over some spacing about programs, obviously just make it look a little nicer and neater, some conventions for that. How you can't, put spaces and stuff. And then obviously Q&A. Awesome. Cool. Prisma is like a backend stuff. Go-to allows us to jump anywhere we want to. Any tips on how to take notes from programming books like these? Honestly, man, I don't really have any tips per se, but just kind of, if you like my style and how I do things, and if you think I've, in your opinion, found success in learning some programming concepts, and through what I've conveyed on the channel, through my personal projects that we've built live here, whether it be the Small Business Managers, our SpectroSim, which is our chemical spectroscopy simulator, our ChromaPlot, our paper chromatography simulator, both of those are web apps. We are our stock analysis tools, our business management tools that we've made, our better options stock thing we've made. What other stuff have we made on here? We've done quite a few things, just randomly making stuff here and there. So anyways, I don't know. I think that I think just watching and taking some notes on and mental notes on how I am maybe doing things. I'm not saying that I'm doing things incorrectly, but it's definitely a good place to start. Yeah. Okay, cool. So we were able to get through chapter 2 here in the note taking. Let's do a quick little recap of what we were able to accomplish for chapter 2. In the notes. So chapter 2 is all about the fundamentals of C, right? So it went over 2.1, introduced writing a simple program, introduced kind of the basic structure of a program with an example here, and went into how we have these directives, which are these hashtag statements that import these kind of H files that contain these various these header files, right? That contain these, or just imports in general. I guess they don't have to be headers, but they contain these imports which have subsequent codes, or what were they called, macro definitions, macros or whatever, right? In there that we can import. We have 3 steps to actually getting a program to run in C. We have pre-processing, which is when a program is first given to a preprocessor, which obeys commands that begin with the hashtag known as directives, and that kind of gets it ready for compilation by putting those directives into their appropriate places. We have compiling, which modifies a program to now be able to translate into machine instructions or object code. And then we have a linking step, which is often intertwined in with the compiling in compilers themselves. But this step combines all the object code produced with any additional code needed to yield the executable program. Kind of links it all together, like all the functions and stuff. Obviously, we have some examples of a few compilers, such as the CC compiler, which is used under Linux or Unix. And we have some various tags or flags that you can do or commands in addition to specify naming of your executable file. We have a GCC compiler, which is supplied with Linux, and it's very similar to the CC. It has some additional features. The general form of, when we moved on to 2.2, which was the general form of a simple program, which we again talked about some directives, which are these hashtag statements at the beginning of our code, which import things that are needed for our programs, or whatever. We have these header files, which are used in tandem with these directives to import these header files, which contain things like the standard library or our own custom header files with our own macros in them. Functions, as we know, are just blocks of code that are reusable, that perform specific actions that we can use over and over again in our programs. Main is the only required function within a C program for what we know right now, and it is kind of the singular requirement for actually having a program run, just having a main overarching function, right? Returns a status code of either 0 or 1 back to the operating system to indicate some sort of status. Yeah. And then we have statements that within our program, within our function, or program like my function, return, yada, yada, yada. And there's a little bit of a typo there. Then we have printing strings, right, which goes into string literals, which are a series of characters that are enclosed in double quotation marks. And then the printf statement, the printf statement obviously voids out those quotation marks and print out what's the characters of the string. We have a new line character, which is where you can delimit areas within your string printing to actually move the cursor to the next line to kind of format your output. We have comments here in C, which you can create comments, multi-line comments with an opening and closing tag of these special symbols. And then you can create just single line comments that encapsulate the entire row of text in or line in that comment with these //. Moving on to 2.4, we talked about variables and assignment, which is a way to store data temporarily in a program for execution, which is a variable, right? Variables have various types within them. These types are like some ones we learned about today were numeric types of int and float. There are more types that we're going to learn about, but I'm sure we'll be getting in them soon. Int and float for now, where int is a short integer. Can store signed or unsigned positive or negative whole integers 0, 1, 3, 92, or negative 2, 5, 5, 3, whereas a float is short for floating point and contains decimal values. But there's some caveats with floats. Arithmetic can be slower, and the value is an approximation, so there could be some rounding error in there. Declarations, variables must be declared before they can use, so we have to declare the variable of their type before we can use them. And then we can assign the variables the values of them. And we can do that in combination as well. We can use these placeholder characters within our printf statement to actually print out formatted variables. And then to actually initialize variables, again, like we said earlier, is you can initialize a variable within the actual declaration and assignment altogether, causing the initializer to be the value of the assignment. And then we obviously can print some expressions in their entirety if we know that we're going to return back a value of an integer. We can assume that and just put it directly within printing expressions here. Scanf was a function we learned about for reading input. This gets input from the user via the console and stores it in a variable. We need to anticipate what the user will give us, such as int or float, and we need to store that within reference to a memory address via this ampersand and store it in a variable. 2.6 is defining names for constants. So this is about macro definitions, which again kind of ties into our header files and our directives. But we can define these definitions here to kind of import into our programs to basically fill in as kind of like their own variables in a sense that are kind of constant. Like predefined variables almost. Identifiers are chosen names for our variables and functions or whatnot, and they have some various conventions to them. And then there's some keywords here that are predetermined by C program that we cannot use, that are saved, such as Python, things like input, print, the same concept applies. You can't reuse things that are already defined. And then a simple layout of a C program, obviously you need to close your, use proper punctuation and close your parentheses, use semicolons at the end of your statements. There's various tokens, which are kind of all of these various kind of identifying characters in C. So that was Chapter 2 review for the reading we did yesterday, going over and polishing up our notes for Chapter 2. I really appreciate you guys being here and hanging out with me. Tomorrow we're going to be going over and going back into Chapter 2 at the end here and completing the practice problems at the end of the chapter. So it looks like there's 10 practice problems and there's a couple of programming projects too, which is kind of crazy. So I'm not sure if we'll do the project, but we'll for sure do the practice problems. Oh, I think the problems are more conceptual, whereas the programming projects are actual programming stuff. So we'll probably actually do them all. So yeah, definitely going to probably do them all because we want to get practice actually writing C code. So definitely going to get some practice with them all. And I like how the sections are actually distinguished on the problems here, so you can refer back to the specific sections and really tie them all together. Really enjoying this book so far. So I appreciate everybody being here. Make sure you guys join me back tomorrow around 7 p.m. PST. We'll complete these exercises. So if you're wanting to do that together, let's do it together. Today, let's see, there's a couple of chats people are talking about. Also, Python better than C because it forces conventions with tab spacing. A lot of C turns into spaghetti. Most people use a formatter with C, C++, so that's an L point, to be honest. Oh yes, for sure, most professional devs. I mean, I use a formatter for Python, so I guess I'm a biggest L for me. If you have to use a formatter for already formatted code, then bruh. No, I'm trolling. Anyways, I appreciate you guys being here. Thanks so much for hanging out with me tonight. This was a lot of fun as we completed this overview and review of chapter 2 and polishing up of our notes. Let's go ahead and add this up to our GitHub. Git add here, git commit. Say, let's say chapter 2, second pass, notes completed. Because we're going to come back through and finalize the chapter tomorrow. And you guys can get access to these notes on my GitHub, link down in the description below if you want to read them over. I think it's a really, if you're wanting to learn C and kind of solidify the information with me, honestly, just doing a quick 10-minute read through of the notes really could give you a clear, really like a good review of what was in the chapter. I really broke it down for you guys. So take advantage of these resources, and thank you guys so much for being here. Make sure you join the Discord link down below and get access to everything. Put a star on the repo if you enjoyed, and yeah. How high can you tell how long this stream lasts? Usually around an hour, minimum an hour and a half, typically, to maximum, like on average, like 3.5, 4 hours, typically, if I'm really in the zone. But minimum an hour and a half. On average, though, it's probably about 2 hours, 2.5 hours. But again, sometimes I get really in the zone when we're coding and do like 3.5, 4. Sometimes we've done like 6-hour sessions. So, but I really like to at least do an hour and a half to 2 hours, because the first half hour we're kind of getting into the flow, and then we start cruising from there. So, anywho, boom. Thank you guys so much for being here. I will see you guys tomorrow. Have a great one. Make sure you subscribe and follow along. Thank you, VTRMQ, for the sub on YouTube 43 minutes ago. I'll replay your alert because I missed it. You are that guy. Thank you so much. I appreciate you. If you guys are not subscribed, if you guys could subscribe, and so I could see you guys tomorrow. And yeah, we've had a lot of love on the channel. Appreciate you guys being here. See you guys. Boom, boom, boom.